Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. We're going to the next mechanism, which is differentiating a simple fraction, okay? Please, you need to make sure you review the previous videos, especially review the laws of indices. And you have to also review the power rules. So it's very important, okay? So make sure you've reviewed those videos on the laws of indices. I have the videos on the laws of indices. And I also have videos on the power rule, which I think is the first video in this series. So make sure you've reviewed that. And like I always say, if you've not liked, shared, or subscribed, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first to know. So you have to click on the notification bell there. All right. So in this, how we're talking about simplified fraction or simple fraction is that in this case, we're having something like if you're having y is equal to a raised to power divided by x raised to power n. Okay. So in this case, where we have a is equal to a constant. So a is a constant and n is equal to a power. Is that right? So for instance, you're having something like y is equal to, let's say, 3 over x squared, something like this, okay? Or you have y is equal to square root of 7 divided by x raised to the power 3 over 2, something like this, and you were told to differentiate. So that means it's having this form here. Y is equal to a divided by x raised to the power n. So how do you differentiate this? Remember, I always tell you, always remember that they must always be in a what? Index form. Don't forget this. This is very key. Before you start differentiating, you have to make sure you've rewritten this in an index form. So that's the reason why I want you to go back and review the laws of indices. Okay, please review the laws of indices. Make sure you're conversant with all the laws, all right? And also make sure you're conversant with the power rule, okay? So make sure you're conversant with both of them because you need both of them to answer these questions, okay? So let's go. So there are 3 rules or 3 steps, okay? There are 3 rules to solve this question. So the first thing you do is that you have to rewrite the fraction. So you have to rewrite a fraction in an index form. Okay, so you have to rewrite the fraction in an index form. Then after rewriting it in an index form, the next thing you have to use any of the differentiation rules, more specifically the power rule with a constant, okay? So usually you have to use any of the differentiation rules that I've discussed previously, okay? So use any of the previously discussed differentiation rule. So any of the previously discussed differentiation rules, okay? So usually the ones that you need to take that usually apply is usually the power rule, okay? The power rules is one of the ones that usually apply. The power rule with a constant. I've talked about this earlier. So usually these are the 2 most important ones that usually apply in this when you're differentiating simple fractions. So mostly it's either the power rule or the power rule is a constant, but the other rules can apply, but this is the most common or the common one you're most likely to use. You're more likely to use here. Then after that, you simplify. So you have to rewrite it in an index form. After that, you then have to apply the rules, the power rules, or the power rule is a constant, or any of the differentiation rules, and you solve it. So basically, we're going back. So we have y is equal to a divided by x raised to power n. Okay, you convert this to an index form, which is going to be y is equal to a multiplied by, this is the same thing as saying 1 over x raised to power n. I remember for those that have watched my videos on the laws of indices, I told you when we talked about this that this is the same thing as saying x raised to power what? Minus n. Are you seeing it? And this is now going to give you y a x raised to the power what? Minus n. So we've converted it to index form. So now we've had it in index form, so we can now say therefore y is going to be equal to ax minus n. Now, when we've converted it to index form, we can now differentiate this, the y over dx. Now we're going to use power rule with a constant. This is very similar to power rule with a constant. So it's going to become the minus n, you multiply this. So it's going to be a multiplied by minus n. There you subtract what? 1 from the power. Are you seeing it? And this is going to give you the y over dx will now be minus an x minus n minus 1. Can you see? So that's how you differentiate that. Are you seeing it? So you basically, you rewrite it in an index form, which we've done. After that, we now use the power rule with a constant to get that as well. So you have to ensure that you review previous videos before you go to the next one. All right, let's pick other examples to make this make more sense to you. So let's assume we have this example here. Okay, we have y is equal to 1 over x. Okay, so the first thing, we have to convert this to an index form. So remember that is the first step. You have to rewrite it in an index form. So if you convert this to an index, it's going to give you y will be equal to x raised to the power what? Minus 1. Now we can now apply the power rule now to solve this. Will be dy over dx will be equal to, you bring down minus 1. So because there's a 1 here, so it's going to become 1 times minus 1. Then x minus 1 minus 1. So dy over dx is going to give you minus. 1 times minus 1 will give you minus. You have x minus what? 2. And that should be the answer for that. Okay. So number 2, let's pick another example. Let's say we are having y is equal to 5 over x raised to the power half. Okay. So the same thing, we'll have to convert this to an index form. So the same thing as saying y is equal to 5 multiplied by 1 over x raised to the power half. So remember I told you in the laws of indices where I said that when you have 1 over x raised to the power n, okay, it's the same thing as saying x raised to the power minus n. Do you remember this? So please try and review my laws of indices. So this is going to be the same thing as saying 5 multiplied by x raised to the power what? Minus half. So therefore, y will now be equal to 5x raised to the power what? Minus half. Then you now differentiate it now because now it's in an index form. So dy over dx will now be 5. So you're going to use the power rule with a constant here. So you're going to be minus half times 5. So you're going to be 5 times minus half. Then x will now become minus half minus 1. So please, if you've not reviewed my video on the power rule with a constant, please go back and have a look at it. And that will now give you, will be equal to minus 5 over 2x. And this will give you minus half minus 1 will give you minus 3 over 2. Are you seeing it? So basically, we're applying the laws of indices and we're applying the rules we are already conversant with. So the next one is number 3. Let's pick another example. Let's say we have y is equal to square root of 2 divided by what? X. Now, like I told you, you have to convert this to an index form. So this is y is going to be equal to square root of 2 multiplied by 1 over what? X. Then y will be equal to, so remember in laws of indices, I told you that you can either, you can rewrite this 1 over x. It can be the same thing as, you can have it as x raised to the power minus 1, all right? So that will give you square root of 2 multiplied by x raised to the power minus 1. And therefore, y will be equal to square root of 2x minus 1. Then with this now, we can now differentiate. So dy over dx, we're going to use power rule with a constant, minus 1. So it's going to be root 2 times minus 1. And you're going to have x minus 1 minus 1. So you bring down the power and multiply the constant, and you subtract 1 from that. And that will give you minus root 2 x minus 2. And that will be the answer for that. Okay, so that will be that. So let me pick one more for this, and maybe we'll call it a day for that. So let's pick, let me push it up a bit here, okay? So we have that. So let's say we have 7, we have y will be equal to 7 divided by 2x raised to the power 3. Okay, so what do you do here? So we can rewrite this again in another form. So we can say y is the same thing as saying 7 over 2 multiplied by 1 over x raised to the power 3. Do you agree? When you multiply this 2, it's going to give you the same thing. So I'm bringing out the constant out. So then I can rewrite this. So remember, in the laws of indices, 1 over x raised to the power n is the same thing as saying x raised to the power minus n. So it's going to give us y will be equal to 7 over 2 multiplied by x raised to the power minus 3. All right, so this will now give us y will be equal to 7 over 2 x raised to the power minus 3. Now we can now differentiate this now. Will now become 7. Remember, the power is going to multiply the constant. So it'll be 7 over 2 multiplied by minus 3 and x minus 3 minus 1. Then when you open the bracket for this, 7 times minus 3 will give you minus 21 over 2 x minus what? 4. And that will be the answer for that. So you can see the key here is that you have to convert it to an index form. All right, before you start to differentiate. So that's why in the rules, the first thing you have to do is that you have to convert it to an index form before you start to differentiate. Then all the previous rules we talked about, the power rule or the power rule with a constant and stuff like that, will apply normally. All right, so I want you to try this. So try with your friend. So let's say we have something like y is equal to 9.9 divided by x raised to the power 4. Let's say we have y is equal to 4 over 7 x raised to the power 5. Let's assume we have y is equal to minus 3 over 4 x squared. And we have y is equal to 3 root 2 divided by 4x minus 4. And we have, let's assume we have y is equal to square root of square root of 7 divided by x raised to the power 4 divided by x raised to the power 2. All right, and you are told to solve this. And we have the last one, y is equal to square root of cube root of 7 divide x raised to the power 4 over 3 divided by x raised to the power 1 over 3. And in all these cases, you were told to find what? You were told to find the y over what? The x. All right. So you can put the answers in the comment section, or you can discuss with a friend. Or if you're not sure, you can stop me around, send me an email. I will talk about how to solve each and every one of them. Okay. All right, and that will be that for that. All right, so we've talked about this is how to differentiate a simple fraction. The first thing that you have to keep in mind is that you have to first rewrite the fraction in an index form. After you've done that, you then have to use the power rule or the power rule with a constant or any of the differentiation rules we've talked about. Then after you've done that, then you can now simplify. All right, the next one we're going to talk about is with reducible fractions. So now we talked about simple fraction. The next mechanism we'll talk about is how do you differentiate fractions that you can reduce. Okay, so reducible fractions. And that'll be the next video I'll be uploading. And if you've not subscribed, please do so and click the notification bell so that when I upload the next video, you'll be the first person to know. So I'll see you soon, and I'll see you in the next video where we talk about how do you differentiate reducible fractions. See you soon.